This is Higher Maths, straight line topic, and we're looking at the equation of a straight line. And we're looking at some different ways that will be asked to try and find the equation of a straight line using some gradients or some points or some other equations. So here's the questions that we're going to run through today. I've got 5 questions that I want to do. If you could stop the video and try them yourself before I show you the solutions to them, that'd be fabulous. If you just want to learn how to do them, then that's okay as well. Right, so what we have here also at the bottom, I've got equation of the straight line questions from the Maths in Action textbook. I've got page 8, exercise 4, and it's going to be questions 1, 2, 3ab, 4, 6 to 10, and that's going to be in the form of y equals mx plus c. We've got page 10, exercise 5. I've got a range of questions there that will be in this form here, ax plus by plus c equals 0. And I've got page 11, exercise 6 for y minus b equals mx minus a form. So that'll be questions 1 to 6 on that one. So let's have a look at these questions here. So these are the ones that we're going to do. So find the equation of the following straight lines, gradient of a half through point 5 minus 2. And generally what I'm going to be using this equation at the top here. So that's y minus b equals mx minus a. Okay, so let's go ahead and try and do these questions. Right, so first question that we have is this one here. So what I do know is that my gradient is equal to a half, okay, and I've got this point here. Substituting into y minus b equals mx minus a, the points that I'm going to use here, that will be my a value here, and this will be my b value. M is going to be a half. So all we're doing is substituting the gradient of a half and the point 5 minus 2 into the equation above. So it'll be y minus b equals mx minus a. So I've got y minus, and remember b is going to be the minus 2, so that will be changed to a plus 2 there. The m value is a half for the gradient, x minus a, which is 5. So there's my equation of a straight line already. So that's me got it there. What I'm going to do is I'm going to prepare this as if I'm going to be doing some simultaneous equations afterwards. So I'm going to try and get rid of the half, and I'm going to try and tidy it up. I'm probably going to leave it in the form of y plus x is equal to the number on the right hand side of the equation. So that's the way I'm going to leave it for some simultaneous equations. Right, so if I've got a half here, what I'm going to do, and the way that I'll do it, is I'll multiply the left hand side by the number that's at the bottom. So that's a 2 that's there, okay? So 2y I'll get plus 4 is equal to, and I'm going to multiply this side out here by the top number. If it's a negative, then I'm multiplying this side out by the negative. So that's going to be 1 times x will give me x, and 1 times minus 5 is going to be just minus 5. And I'm going to leave it in the form of 2y, bring the x over to this side, becomes a negative, bring the 4 over to that side, that becomes minus 4, so minus 5 minus 4 gives me minus 9. So that will be the answer to the first one that I'm looking for. Question 2. Different form here. So I want to know the equation of the straight line through the points P and Q. Right, so what I had up above, I had a gradient. So I'm going to try and work out the gradient, and then I'll use either that point or that point in the equation of a straight line, the y minus b equals mx minus a. Let's work out the gradient first of all. So the gradient of PQ is going to be equal to y2 minus y1 all over x2 minus x1. From there I'm going to go for 6 take away 0, 1 take away minus 2. That gives me 6 on the numerator, it gives me 3 on the bottom there, and that gives me 2 as a gradient. Right, so I've got my gradient now, and I can choose either one of these points. Now which one will I choose? Well, this one doesn't have any negative numbers in it, so I might just choose that one. That has a 0 there, that might help me out as well. I'm just going to go for the one that doesn't have negative numbers in it. So I'm going to substitute the gradient equal to 2 and q 1 6 into the equation of a straight line, which is y minus b equals mx minus a. And remember, what I'm going to do is, this is going to be my point A, this is going to be my point B. So here we go, we've got y minus b, which is 6, is equal to m, which is my gradient, which is 2 bracket x minus 1. So that's me got my equation of a straight line already, but get it into simultaneous equations form, because normally what we're doing is, in the straight line questions, we will have to put it into that type of format because we're looking at points of intersection of two lines. Right, multiply the right hand side out here, so we've got 2x minus 2, gather the x over to this side, it'll be minus 2x, 6 goes over to that side, becomes positive 6, so minus 2 plus 6 gives me 4. So what I've got as an equation is y minus 2x equals 4. And that's me ready to do any simultaneous equations work with that one. Right, let's look at the next question here. Just a little bit different again. So what I've got is, I'm trying to find out the equation of the following straight line. It's perpendicular to this line here, and it's through that point. So there's my a and b value there that I'm going to have to use, okay? Right, so what I'm looking for is the gradient of this line, and what I have to do first of all is get the equation into a different form. So I've got to get the equation into y equals mx plus c, because from there what I can do is I can grab the gradient that's there, but it must be y equals, not 4y, not 5y, must be just y is equal to mx plus c, okay? Right, so let's start with the equation that we have here. 4y minus 3x equals minus 5. Right, so what I'll do first of all is I'll get the minus 3x over to the right hand side. So 4y is then going to be equal to 3x minus 5. It's 4y I have here, and remember I was saying I must get y on its own, so I'm going to divide both of these by 4, because there's the 4 there. So that's going to give me 3/4 x minus 5 upon 4, and that's what I'm looking for there, okay? So remember what I've got here, this part here is going to be the gradient, so that's my gradient of this line. And this part here, remember, is going to be my c value or my y-intercept. That's what that is for that straight line there. Right, so I know that the gradient here, the gradient of this line here is 3/4. So if I wanted to find out the perpendicular gradient, so remember what we did in the previous clip, perpendicular gradient, all I'm going to do is flip that over, 4/3, change the sign. So it's going to be minus 4/3. And the reason that I know that is because gradient 1 times gradient 2 equals minus 1. Just a statement for that. So this is the gradient I'm going to use. This is the point I'm going to use. So that's me set up again to go ahead and do that. So I'll substitute the gradient, and it's minus 4/3, and the point P, which is 5, 6, into the y minus b equals mx minus a. Right, so it's going to be y minus the 6 is equal to the gradient minus 4/3, open bracket, x minus 5, okay? That's we started it off there. Right, so what I was saying earlier is that if I try and sort this out, I'm going to multiply the left hand side by the 3 to get rid of the fraction. So that's going to give me 3y minus 18 is equal to, I'm going to multiply the right hand side out by minus 4. So that's going to give me minus 4x, and that's going to give me plus 20. What I'll then do is just rearrange it. So I've got 3y here, bring the minus 4x over, that'll give me plus 4x, and from that side there I'll bring the 18 back over to that side, and that gives me 38 on that side there. And that's me set up for doing any simultaneous equations work that I have to do after that one. Right, let's look at this question here. So what I'm trying to find here is the equation of the straight line through the points P and Q. So that's quite similar to what we did earlier, but there's a wee twist in this one here. Let's work out our gradient for this one here. So the gradient of PQ is going to be equal to y2 minus y1 all over x2 minus x1. Okay. When I work this one through here, what I've got is I've got minus 2, take away minus 5, all over 7, take away 7. And from there, what I've got on the top, so it's minus 2 plus 5 gives me 3, and on the bottom there I've got 0. If I work this out here in the calculator is going to give me a math error, and that gradient is undefined. So the gradient is undefined. Okay, and what that would generally mean is that a straight line through these points, if you look at what the points are, so it's 7 minus 5, 7 minus 2, the x values are the same, so an equation of a line that has an undefined gradient is vertical. So for this one here, the equation is x is equal to 7. So what it is just a vertical line going up all the way where x equals 7. So that's the equation there. So just watch out for these ones when the x coordinates are the same and you've got an undefined gradient. Right, so the last question here, what we've got is we have to find the equation of the straight line through the point A, which is 2 minus 1, and it's going to be perpendicular to the line joining these here. Okay, so again what I'm going to do is find the gradient. I'm going to then work out my perpendicular gradient and use the point A. Okay, so this point here, I'm going to use that as my A value, that there is my B value. Right, so first of all we'll work out the gradient. So the gradient of BC. So we'll start with this one, so 2 minus 0. And we've got 3 minus minus 2, which gives me 2 on the numerator, and we've got 5 on the denominator, so 2 over 5. And what I can do from there is I will take the perpendicular gradient for that one there. So it's not that gradient I'm after, it's the perpendicular to that line there. So the gradient of the perpendicular is going to be equal to, flip it over, and change the sign. So that's 2 over 5, so that's going to be minus 5 over 2. And you know why I know that? It's the two gradients multiplied together equal minus 1 for perpendicular lines. Right, what I'm going to do next is I'm going to be substituting this gradient and this point, because that's the point that we're interested in, and what we should get there is our equation of the line from there. So substitute the gradient, and it's minus 5 over 2, and the point A, which is 2 minus 1, and that'll be into y minus b equals mx minus a. Right, so y minus b, which will be this value here, so that's minus 1, so that's going to be a plus 1 that's going to be appearing there. I've got minus 5 upon 2 x minus, and the value for a was 2. I'll then do times this side here by the 2, so it'll be 2y plus 2. On this side here on the right, I'm going to multiply out by minus 5, so minus 5x, and that's going to be plus 10, because the two minuses multiplied together. Gather the y's and the x's on the left hand side, so I've got 2y plus 5x is equal to, bringing the 2 over becomes a negative, and that's going to be 8. So I've got 2y plus 5x equals 8, and I'm all set up to go and do any simultaneous equations work that I have to do from there. Okay, so that's that part complete, and what I would like you to look at is the questions that I put in here from the Maths in Action textbook. So the various different forms that you'll be using the equations, and to try and gather the information from the questions that are here. So there's a bit of variety there. So good luck with the equation of a straight line.